everyone. I'm Rinkal Sardhara, working as an assistant professor in LJ Institute of Computer Applications. In today's sessions, we are going to discuss Kruskal'S algorithm. Through the Kruskal'S algorithm, we can generate minimum spanning tree. Now, question comes in our mind is, what is minimum spanning tree? First, we discuss the spanning tree. A spanning tree of an undirected graph G is a subgraph of G that is tree containing all the nodes of graph G. Now, the minimum spanning tree is a subgraph of undirected graph such that the subgraphs includes all nodes, is connected, is acyclic and has minimum total edge weight. Let's discuss the steps to create the Kruskal'S algorithm. List all the edges of graph G in increasing order of weights. Select the smallest edge from the list and add it into the spanning tree. If the inclusion of this edge generates the cycle, then remove that edge from the spanning tree. Repeat step 2 to 3 until the tree contains n-1 edges or list is empty. If the tree T contains less than n-1 edges, then the no spanning tree is possible for that particular graph. Now let's take example to create a minimum spanning tree through the Kruskal'S algorithm. Here graph is there. We have to do the first step. The first step is list all the edges of graph in increasing order. So list the edges. The minimum edge in this graph is A to D having weight 1. The next edge is 2, that is C to E. The next edge is B to D having value 3. The next is 4, that is D to E. Value 4. The next is 5, that is B to E. Next one is 6 of edge BC. Next one is 7 A to E. Next is 10. Next one is 12. Here total number of edges is 1, 2, 3. That is total 9. We had done increasing order of all the edges of this graph. Now we have to select one by one edges and add it into the minimum spanning tree. The first edge is A to D. Select that edge. As right now we do not have any node in minimum spanning tree. The minimum edge is A to D, so draw that edge into the minimum spanning tree. The next edge is C to E. Cycle is not there, so you can add that edge into the minimum spanning tree. Next is B to D. Again, cycle is not there, so you can add that edge into the minimum spanning tree. The next stage is D to E. You have to repeat this step until you didn't get n minus 1 edges. Here, total number of knots is 5. So, you must have 4 edges. Here, 4 edges is there. So, there is no need to check all other edges. Just keep all the edges as you get minimum spanning tree, right? This is a minimum spanning tree. The total weight is 1 plus 2 plus 3 plus 4. Total is 10. The minimum spanning tree is ready. The application of this algorithm is to find the shortest path, and as well it is useful in computer networking. Here I had kept one more example for practice. Do it by your own self, and if you have any problem then contact me at rinkal.sardhara@ljinstitutes.edu.in. Thank you.